slope fields are another, way for us to get information. Sorry, I need to fix this. Okay, so slope fields are another way for us to get information. Oh, this is why. Aha, I fixed it. Slope fields are another way to get information about a differential equation without knowing the actual solution, and to get information about the solution, okay? So tomorrow we will learn how to solve a differential equation. Well, certain kinds, not all kinds, but certain kinds, okay? But when we're looking at a slope field, it literally is a field of slopes. It is a bunch of different little slopes. Now, why in the world would a differential equation and slope have anything to do with each other? Why would... What is it the slope of? What is the derivative slope of? The tangent line, right? So with this equation right here, what could you tell me about the slope of the tangent line that is through the point 0, 5? If we have a solution to this differential equation and it goes through the point 0, 5, what could you tell me about the slope of the tangent line of that solution at that point? What is the derivative at that point? If x is 0 and y is 5, what's the dy dx at that point? 0. So what's the derivative at that point? So what's the slope of the tangent line at that point? 0, right? So you know the solution, whatever it is, has a horizontal tangent at 0, 5, right? Any other places where you know that this function, this solution, these solutions, multiple solutions would have horizontal tangents? What about 0, 2? Will the slope of the tangent line be 0 at 0, 2? What about 0, 1? Yeah? So when we draw a slope field, we're going to draw a little mini tangent line to show what the slope of the tangent line would be at each point. So at 2, 0, if you plug in 2, or I'm sorry, not 2, 0, 0, 2. If you plug in 0, 2 into this dy dx at 0, 2 will be negative 0 divided by 2 times 2, which will be 0, right? So the tangent line will be horizontal at 0, 2. Where else on this graph will the slope of the tangent line be horizontal? What other points besides 0, 2? 0, 1. Will it be 0 at 0, 0? Yeah, what's going to happen at 0, 0? What will dy dx be? 0 over 0, which is undefined, right? So there will not be a tangent line at all here. It's undefined. The slope, the slope of the there will not be a slope there, right? There will be a tangent line there, but there will not be a slope there, okay? How about, you said 0, negative 1 and 0, negative 2. What will be the slope of the tangent line at 1, 1? Negative 1/2. If you plug that point into the derivative, you'll get negative 1 over 2 times 1, which is negative 1/2. So at 1, 1, the slope will be negative 1/2. So it'll look about like that. So what we're doing with a slope field is we're just drawing what the tangent line will look like at that point on the solution, right? On the solution that passes through that point. There's a solution that's going to go through this point, and that's what the tangent line will look at. Okay? So when you're drawing a slope field, a lot of times these are for your response questions on the AP test, and they don't really care about how accurate they are. But we can definitely see some stuff changing. So for instance, what will be the slope at 1, 2? What will be the slope of the tangent line at 1, 2? negative 1 over 4, right? So that'll be a little flatter than the one we just drew, right? They don't really care that much how accurate you are about like the steepness, right? That's kind of hard to grade. So what you really care about on your slope fields is positive, negative, 0, and undefined. Those are the things you really want to look for. Positive slopes, negative slopes, 0, and undefined. We said the slope was undefined at 0, 0. Are there any other places where the slope will be undefined besides 0, 0? Anywhere along here, right? 1, 0, 2, 0, negative 1, 0, 2, 0. If you plug in 0 for y, it's going to be undefined, right? So there should not be any slopes, tangent lines drawn around here. What about these two have been negative? Where in general, what values of x and y in general will the slope be negative? In this quadrant right here, will the slopes be negative? Why in this quadrant? Because x and y are both positive. You plug in a positive x and a positive y, the slope's going to be negative, right? So they're all going to be negative here. If you plug in the actual values, you'll be able to see that the steepness changes a little bit and it gets a little steeper out here at 2, 2. Or I'm sorry, at 2, 1, it will be exactly 1, negative 1. Where else will the slopes be negative? In what other quadrant? This one right here, right? Because if you have a negative x and a negative y, those will become positive and then you have an extra negative in there, right? So all of these are going to be negative slopes. What about up here when x is negative and y is positive? What will the slope be? Positive? What about down here where x is positive but y is negative? So a negative divided by negative will make a positive. And this is what we call a slope field. So a slope field tells you information about the slope of the tangent line. All of these are little mini tangent lines for solutions that go through them, right? So there's a solution that goes right through this point, and it's probably coming up at about like that if that's what the tangent line is like, right? At this point, the solution's going to hit like a little maximum, right? Because this is a horizontal tangent, right? When it goes through that point. Here, we'll have like a little minimum when it goes through that point, right? So these are telling you about the slopes, but they're also giving you an idea of what the solution looks like, right? You can kind of see if you follow the curve, follow the waves, what the solution is going to look like. Specifically, part B asks us to draw a possible solution curve for the solution that passes through the point 0, 1. So if I have the point 0, 1 here, I can draw an approximate curve that will pass through that point. It'll look approximately like this. It's going to definitely go through that point. It's definitely going to have a horizontal tangent there. And then if I follow the waves, I can see that it's going to look like that because I can see how the slopes are changing. And what you've done here when you pick a particular point is you've picked one solution, right? There are infinitely many solutions to this differential equation because you'll put a plus c on the end, right? When you find the antiderivative, okay? And so the second you pick one of those, you have now found c, right? And you have zeroed in on one solution. So that's a slope field. When you're looking at slope fields, the main thing you want to pay attention to is positive, negative, 0, and undefined. So let's look at an example of a common type of multiple choice question. Here we have a slope field, and we have some possible differential equations. So on this graph, some of them, you always want to try, when you're trying to figure out what differential equation or when you're drawing values, you want to pay attention to 0, undefined, positive, and negative. There are no places here where this one is undefined, but there are some spots where the slope of the tangent line is 0. Where are some of the spots where the slope of the tangent line is 0? These guys all right here. So like this one is 1, 1. This one is 2, 2. This one is 3, 3. This one is 4, 4, right? So where y and x are the same. So which ones of those equations will give you 0 for the slope when y and x are the same? Will this give you 0 when y and x are the same? Like y, they're both 3? Will this give you 0 when y and x are the same? Like they're both 3? Yes? Will this give you 0, c give you 0 when y and x are the same? If x is 3 and y is 3? Well, this one? Yeah, negative x plus y, if they're the same value, right? Negative 3 plus 3 would be 0, right? So both of these will be 0, like if you look at the point 3, 3, or 4, 4, or 5, 5, both of those will be 0. But this one definitely won't be, right? It'll be 9 minus 3, okay? So this at least takes away a and d. A and d are not possible differential equations because when all of these points where y and x are the same, the slope needs to be 0. So now you need to figure out which one of those is. So pick another point. Any point. What's the point you want to pick? 0, 2? Is that what you said? 0, 1? All right, 0, 1 right here. What do you notice about the slope at 0, 1? It's 1, specifically positive. Even if you're not 100% convinced it's exactly 1, right? But it's definitely a positive slope. Which one of these equations, when you plug in 0, 1, do you get a positive slope? Do you get a positive slope here when you plug in 0, 1? No, you get a negative 1. Do you get a positive slope here when you plug in 0, 1? You get negative 0 plus 1, right? Would be 1, right? So which one does it have to be? C, right? Because this would give you a negative 1 if you plugged in the 0, 1. So you can really pick any points you want. You might not get lucky. Maybe you pick another point and they're both still the same slope at that point that matches the graph. Well, then pick another point, right? You can pick any point you want. Every point on this graph better match that slope. Any questions? Okay, let us do another example here. Okay, so this says the graph to the right shows a slope field for the function y equals f of x. So this is a slope field, and they want us to draw, if the initial condition is 0, 6, so we're looking at a solution that goes through the point 0, 6. What is the range of the solution curve for blah, 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 blah. So they're saying if the initial condition is 0, 6, they have now focused in on a particular solution. So as long as you're writing in pencil, I want you to try to draw what you think a curve would look like, a solution going through that point in 0, 6. Follow the waves, follow the lines, follow the curve, and draw what you think a solution will look like going through that point. If you're drawing in pen, maybe wait. Just make sure you don't draw anything crazy. Unless it's a erasable pen, or you're very confident. So we know that it's going to go down. We can see if we follow the waves, it's going to go down. It's getting a little bit more steep, or a little less steep each time, a little flatter, 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 flatter. Do you think that it's going to go through this part right here? Do you think it will touch this part right here? It's going to get closer and closer. And how do we know that? Well, if it goes through there, then it would have to have a slope at an angle, right? If it goes through that part, right? It can't be 0. To go through there. And so it's going to get closer and closer and closer and closer, but never touch. Okay? Now it asks for the range of this solution, but note that it says for x greater than or equal to 0. So we want to cut off this part up here. Right? It only wants from x greater than or equal to 0. So what's the highest that value will be then of the solution? 6, and what's the lowest that function will get to? Get something greater than 4, right? It won't actually reach 4 to get closer, so the range, you can write it in interval notation if you want. we'll go from 4 to 6, or if you want to write it in inequality notation, f will always have to be less than or equal to 6, but greater than 4. And another interesting note, this was actually on one of the AP tests recently. While you know that this doesn't actually touch 4, you know it gets closer and closer and closer, right? So you know that the limit as x approaches infinity of your function f, remember f is the solution you just drew, what would that limit be equal to? What would that limit be equal to? 4, right? Isn't that what that means? When it gets closer and closer to 4 but never actually reaches it, you know that that limit would be equal to 4. So special little fact there. All right, so example 4 now, they've given us another slope field, and you are picking one of these to be the solution now. Not the actual differential equation, right? But what the solution would be. So if you pick a point, right, at some value of c, what do you think the solution is? So I want you to try 4 on your own. Try 4 on your own. See if you can figure out what solution that is. Remember, the solution would be the line that you would draw on the graph. Go ahead and talk about it with your table if you haven't already. I think you just need the derivative of each of them, right? I think the derivative. Because this is the slope, and that's like the equation, right? Or like that's all you have to do. If you see that, I wish everyone follows the same secret box report that is the slope field, like do it first.
Yeah, I have a question. Did you just forget some of those things you were from yesterday, right? Or let's see, or I didn't see it. Yeah, it's video for it. So I got to the homework and I had no idea what I was doing.
I thought that I had one for you. You didn't have those for me.
Okay. Which starts with sign. Come on. Okay, what if I already do this? I just go 4. Yeah, I'm like, oh, this is the yeah, I know. But like, yeah, I'm just worried that if I update that with this, like, no, you get 1 year free. What did you get? What? Wait, what is E? Yeah, I said echo. E? Yeah, I said echo. Oh, E, that makes it C. So sorry.
Yesterday I don't have a video for yesterday's notes, but I posted.
I can teach you 2, don't worry. Okay, it's not that bad. It's just taking second derivative. Is there like a faster way of than like plugging and chugging? Because that's what I used to do last week.
Well, for certain types, yes, but yesterday's homework, no. Everything you just have to check. The slope fields?
Like when it asks you to draw.
Yeah, you shouldn't be plugging in every single value. You should do exactly what we just did. Like, where is it? Positive, 0, negative, and undefined. That's it.
Okay, and then you
Yep. Yep. So if you draw like a little curve here, maybe you drew it up here. It's not the best one. It's definitely clearly a sine or a cosine, right? So how are you going to figure out which one it is? Look at 0. I like that. Specifically, let's look at 0, 0. What do you know? When you plug in 0, what should you get? This is a really important question. When you plug in 0, what should you get? What does this tell you? What is this? So I agree that the slope at 0, 0 is what? It's a 1. Can you see that there's like a little slope there? The slope at 0, 0 is 1. But does that mean that if this is a solution, does that mean if I plug 0 into this, I should get 1? No, right? If it's going to go through this point right here on the graph, it means if you plug in 0, you should get 0, right? What you're saying is if you plug 0, 0 into dy dx, that's when you should get 1, right? So if this right here shows you that it goes right like this, so which one of those functions, when you plug in 0, do you get 0? Sine or cosine? When you plug in 0, which one gives you 0? Sine, right? This right here is a graph of sine, not cosine. Now, what does that mean dy dx will be, though? What's the derivative of sine? Cosine, right? Which is why when you plug 0 into this, what should you get? What's cosine of 0? 1, and that's why the slope there is 1 at that point, right? So what we're asking for here is the solution equation, right? Not the dy dx that generates the whole slope field, right? That would be cosine of x. So here, the solution is just sine. And every single one that you would draw here, every single solution would just be shifted up or down 1c, right? If you draw it right here, this is plus sine of x plus 1, right? Draw it right here, that's sine of x plus 2, right? That c is just going to give you all of these sine curves. These are all sine curves, right? Just differing by a constant, okay? All right, try the last one. You're finding all the points, you're describing all the points in the xy plane. That slopes will be positive, that differentiation.
That's 13 greater than negative. You're right. You're right. I'm just making that down. No, because then it's, I would have put 0. Yeah, it's if you negative that. Oh,
X have to be positive?
negative 1.
If you haven't already talked to your table about it, talk to your table.
If you do negative 1, that's
And x is 0.
yeah. I don't know why I said negative 0. Yeah. Well, actually,
But if it's 0, would it be positive? That's what I didn't know.
I think it's just
I think so. Yeah, I was thinking, oh yeah, that's true.
$200 is quite right there. It looks so bad too. And there's definitely like a couple of them on this, yeah, it's that's your divide. It's like even if you don't get it, you just fucking have it with X. Like you have to get board by 0. Yeah.
If you don't realize that too, because the fine, you'll solve it, you'll get an answer, right? But it's not. I'm not.
Yeah, but
I did it wrong and you still got it right.
I don't know how to use a split policy. I don't see my teammates use it like randomly. Like sometimes
All right, what values will this always be positive? When y is greater than 1, does it matter what x is? No, why not? Because of the square, right? But that's actually not a good enough answer. Not just y greater than 1. X cannot be what one value? 0. Why can x not be 0? Because if x is 0, what would you get? 0. And is that positive? No. So here, this is when y is greater than 1. And x is not 0. So it doesn't matter completely what x is, right? As long as it's not